In this lecture, we talk about cup product on Klein bottle with coefficients in z modulo 2z. So here we will construct Klein bottle from projective planes. So Klein bottle is actually a connected sum of projective planes. So this we have described in the lecture on connected sums. So you take two projective planes, take the connected sum, and you get a Klein bottle. So now this description of Klein bottle is represented like this. So there is A here and B here. So say this B comes from this RP2 and this AA is coming from this RP2. So now we are considering coefficients in Z2, but to compute we have to fix our orientations. So orientations we are going to fix is 0, 1, 2. So we are going from 0 to 1 to 2, and then we are going to fix 0, 3, 2. So 0, 3, 2. Like this and like this. So we are working with the cohomology. So for homology we consider edges. For cohomology we have to consider functions which act on these edges. So for on A we will have alpha acting on it, and on B we will have beta acting on it. So we have this alpha which is acting on both the edges. So this alpha lies in C1 and dually this A lies in this C1, and we are going to say alpha of A is 1. So alpha is dual to A. Similarly for B we have beta acting on it. So beta again lies in this cohomology part. B lies in the homology part, and beta acting on B gives you 1. So the important observation is that alpha acting on B gives you 0 and beta acting on A gives you 0. So beta acts on B and alpha acts on A. So recall that our cohomology groups in coefficient ring Z2 is just Z2, H0, H1 is Z2 direct sum with Z2, and H2 is just Z2. Now in cup product, this H0 is always an identity because cup product is a graded ring structure. So we are going to cup H1 to land in H2, and higher cohomology groups for Klein bottle are all 0. H3, H4 and so on are all 0. So elements of H0 are just identity because they are on grading 0. So only grading we are worried about is 1. And cup products of elements in H2 will lead to 0 because you cup any element in H2 with anything in H1, you will land in H3, which is 0. Cup H2 with element in H2 itself, you will land in H4, which is 0 because the grading adds. So this will form a graded ring. So cup product of elements in H2 will only lead to 0 since this H superscript I is 0 for I greater than 2. So thus we only focus on H1. On H1 we have two elements, alpha and beta. So say alpha sits here and beta sits here. So first we compute alpha cup alpha on our two beautiful triangles 0, 1, 2 and 0, 3, 2 according to orientation we have chosen. So 0, 1, 2. So alpha acts on 0, 1, the first part. 0, 1 is just A, and 1, 2 is also A. So this is A and this is A. So alpha acting on this part gives you 1. Here also gives you 1. 1 times 1 gives you 1. Now alpha cup alpha on 0, 3, 2. So obviously alpha is not even in this triangle. So you have alpha acting on 0, 3, which is B. So alpha acting on B is 0. So this first portion is 0. And second portion alpha acting on 3, 2, which is again B, which is also 0. So you just get 0. Now beta cup beta on 0, 1, 2. So 0, 1, 2. So you see that beta is not even in this triangle, so it cannot act on A. So beta on 0, 1, as you see here, is 0. Beta on 1, 2 is also 0. So you get 0 times 0. So beta cup beta on 0, 3, 2. 0, 3, 2. So you have first 0, 3 and then you will have 3, 2. So beta on 0, 3, 0, 3 is just B. So beta is acting on B, you get 1. Beta acting on 3, 2, you also get 1. So you have 1 times 1, which will give you 1. alpha cup beta on 0 1 2. So alpha acting on 0 1, this will give you 1 because there is a here. So 0 1 gives you 1, and then you have 1 2. So beta acting on 1 2, this is just a, so it will give you 0 here. So 1 times 0 will give you 0. So alpha cup beta on 0 3 2. So alpha acts on 0 3 and then beta acts on 3 2. So 0 3 is our B and 3 2 is our B again. So alpha acting on B will give you 0, so this portion becomes 0. This will give you 1, and 0 times 1 will give you 0. So we see there are only two non-zero items, this one right here and this one right here. So this is alpha cup with alpha, and this one is beta cup with beta. So we have alpha cup alpha is equal to beta cup beta. They generate H2, because H2 is just consists of this upper triangle and lower triangle. So components of H2 are just 0 3 2 and 0 1 2, and 0 1 2 is generated by this, and 0 3 2 you can see is generated by this. So both of them generate H2, and alpha cup beta is 0, beta cup alpha is also 0. So this you can see alpha cup beta. We can also compute beta cup alpha, it will also give us 0. So a graded ring structure is H2 alpha beta, and then you have alpha cube and beta cube right here. So alpha cube and beta cube, they are 0 precisely because we do not work in 3 or higher. 3 or higher are all 0, so this will be 0. Alpha beta, as you can see, alpha beta or beta alpha, they are also 0. So you have alpha beta here, and this equality here, because they generate H2, this equality becomes alpha square minus beta square. So we have been able to compute cup product on Klein bottle using connected sum of RP2 with RP2. So we will have another version in which we will use the standard form of Klein bottle. So rather than using this small little trick, we will just use the standard form of Klein bottle, and from there we will compute the cup product, and it will require slightly more effort.